day everyone, my name is Keshni Morgan and I'll be presenting my final year project part 1, which is prediction of heart failure using support vector machine. In this video, we will be covering 5 chapters which are introduction, literature review, research methodology, research design and implementation, and finally conclusion and recommendations. Now we will look into the introduction of chapter 1. Heart faces many problems such as heart failure, heart attack, arrhythmia, valve disease and inherited heart diseases. According to World Health Organization, around 6.2 million adults in US above the age of 35 have already had a heart failure from the year 2018 to 2020. According to American Heart Association, the heart will undergo 3 different measures in order to fix this lack of pumping blood, which is enlarging, developing more muscle mass, and pumping faster. As we all know, machine learning is a part of artificial intelligence which uses techniques to train the data and predict the output. Now we will look into the problem background of this research. Based on the study conducted by James in year 2019, which is Global Burden of Disease, Injuries and Risk Factors, it can be seen that around 64 million people worldwide are living with heart failure. Not only that, based on the study conducted by Jones in 2019, which is statistical analysis of the Rotterdam study, it can be seen that at the mean age of 70.4 years, more women are at the risk of heart failure compared to men. Not only that, heart failure has so many causes, which is hypertension, diabetes, cholesterol, bacterial, internal conditions, and exercise-induced angina. This may lead to difficulty in identifying the heart failure manually through signs, symptoms, or physical examination. Not only that, from the study by Bharati at year 2021, it has been concluded that machine learning performs the best in analysis where they use the random forest, logistic regression, k-neighbors, XGBoost, SVM, and decision tree by comparing their accuracy through 3 different approaches. But in the same study, it also can be seen that deep learning algorithms also have given better accuracy percentage than some machine learning algorithms in these approaches. Since there was not much research on predicting heart failure using machine learning and the existing studies did not give a promising results in predicting and analyzing heart failure. Not only that, heart failure is difficult to predict through scanning or symptoms, and different machine learning algorithms provide different performance metrics when undergoing different feature selection methods. Therefore, this research will be focused on implementing support vector machine algorithm in predicting heart failure based on classification accuracy and algorithm efficiency. The research question will be: first, how can heart failure can be studied and predicted? Second, what technique can be used for feature selection to predict heart failure? Lastly, how support vector machine evaluate heart failure performance using accuracy, precision, and recall. So the research objective will be to study the heart failure and machine learning performance using the data set on the prediction of heart failure. Second objective will be to develop the recursive feature elimination, which is RFE, support vector machine SVM approach in the selecting significant features of heart failure. Lastly, to evaluate heart failure performance using RFE SVM by acquiring accuracy, precision, and recall. The scope of the research will be to predict the heart failure that causes most death globally. Not only that, for this research, the dataset was taken from Kaggle, which focus on heart failure. Lastly, Python language will be used to run the support vector machine algorithm in this project. Now we will look into the research contribution. This research will be contributed to bioinformatics field by providing a solution in predicting the heart failure using support vector machine algorithm based on this data set in order to improve the accuracy in predicting the heart failure. It also uses Python for the pre-processing and analysis part to produce accuracy, precision, and recall. Now we will look into the introduction of chapter 2. This chapter will provide classification of heart failure and its diagnosis technique. Not only that, the classification of machine learning heart failure also will be further discussed in this chapter. Lastly, this chapter also discusses feature selection method and machine learning algorithms. Now we will look into the types of heart failure. There are 4 types of heart failure, which are biventricular, high output, left-sided, and right-sided. In biventricular heart failure, the both left-sided and right-sided are affected. The symptoms will be breathing problems and fluid retention. For high output occurs when the heart can initially circulate blood through the body effectively. That is when with preserved and lowered ejection fraction, but it's unable to keep up with the body's rising blood demand. Eventually, the heart weakens and it's unable to adequately pump blood throughout the entire body. For left-sided, due to the lack of ability of left ventricle to circulate the blood throughout the body, leading to blood accumulation in the pulmonary veins. This will result in breathing issues, coughing, or shortness of breath while engaging exercises. This is typical type of heart failure occurs on the left side. For right-sided, due to the lack of ability of ventricular to circulate blood to the lungs effectively. Now we will look into the stages of heart failure. There are 4 stages in heart failure, which are stage A, B, C and D. Stage A and B are the pre-heart failure. Stage A might occur since their congestive heart failure runs in the family or the patient have hypertension, diabetes, coronary heart disease or other medical condition. Stage B occurs when the left ventricle isn't functioning well or is anatomically incorrect but hasn't experienced any heart failure symptoms. For stage C, the heart failure is the diagnosis for the people in stage C and they presently have or in past might have heart failure. The advanced system of stage B, heart failure with reduced ejection fraction, are unaffected by therapy. Heart failure has now reached its climax in stage D. Now we will look into the diagnosis technique. There are so many scans to identify heart failure, which are echocardiogram, electrocardiogram, EMI and CT scan, MRI and X-ray, multi-gated acquisition scan, which is also called MUGA, or DNA or genetics test. Heart failure also can be tested through their cholesterol or hypertension, blood pressure, everything. Now we will look into the classification in machine learning for heart failure. Classification utilizes label input data since it's supervised learning approach that includes input and output data. In order to detect the same pattern in new data sets, algorithm runs on training data, which essentially a type of pattern recognition in classification. To improve medical diagnosis, feature selection and machine learning techniques have been put into the practice. In the study conducted by Lee at year 2020, which is heart disease identification method using machine learning classification in e-healthcare, he proposed and compared machine learning to predict heart failures such as SVM, KNN, NAIF-based, decision tree and logistic regression. Now we will look into the feature selection method. There are 2 types of feature selection method, which is supervised feature selection and unsupervised feature selection. In supervised feature selection, there are 3 methods, which are filter methods, embedded method and wrappers method. In filter method, there are many types of filter methods, which are missing value, information gain, chi-square test and feature score. For embedded method, there are regulation L1 or L2 and random forest importance. For wrapper method, we have forward feature selection, backward feature selection, exhaustive feature selection and recursive feature selection, which is RFE. RFE lowers the complexity of a model by selecting important characteristics and eliminating less important one. The selection procedure gradually removes each of these less important qualities until it reaches the ideal number required to ensure top performance. In the research conducted by Newers in 2021, which is survival prediction of heart failure patients using machine learning, he used feature selection method, which are chi-square test and RFE, whereby RFE shows better score compared to chi-square test. Now we will look into support vector machine. What is support vector machine? Support vector machine is a supervised machine learning that applied to classification or regression issues. The best possible classification and separation of data point into 2 classification points are achieved by identifying the optimal separating hyperplanes. In the image, we can see that there are positive hyperplane and negative hyperplane and maximum margin. Each piece of data in support vector machine method is represented as a point in n dimensional, where n is the total number of features and each feature value identified as a specific position. The classification is carried out by locating the ideal hyperplane to separate points in data by their class so that they can be categorized. From the study by Lee 2020, the conclusion states that the accuracy of support vector machine with the proposed feature selection algorithm is the highest, which is 92.37%. These are the review of previous study on heart failure using machine learning algorithm that I have conducted. I conducted a review of around 10 papers. Now we will look into the research gap. After conducting multiple studies, it can be seen that the most of the research paper used data set are small in quantity, where the machine learning accuracy can be improved with huge data set. Not only the previous research paper did not show the pre-processing method, where they did not specify which selection method they are using and did not provide a complete table comparison with other machine learning method. In addition, authors of certain research paper also did not specify which machine learning is suitable for the research. Now we will enter the chapter 3, which is research methodology. The research framework is described in this chapter to show full scope of necessary steps. Not only that, this research work has been divided into 4 major sections, which are phase 1, phase 2, phase 3 and phase 4. The description of the dataset was selected and performance measurements were followed. The hardware and software prerequisites for carrying out the research also has been specified in this chapter. This is the framework of this research, where it has phase 1, phase 2, phase 3 and phase 4 and ends with thesis writing. Now we will look into the phase 1, which is research, study and literature review. All relevant information and materials were taken from various resources such as journals, academic websites, books, articles and many more. Since it's crucial to analyze pattern and conditions and clarify the goals and objective of the current investigation, a detailed analysis of the proposed research has been conducted. The dataset used in this research is the heart failure dataset from Kegel. By completing this phase, the first objective of this research, which is to study the heart failure and machine learning performance using the dataset on the prediction of heart failure, has been achieved. Now we will look into the phase 2, which is design, develop and implementation. There are 3 subphases in this phase 2, which is phase 2A data preprocessing, phase 2B feature selection and phase 2C support vector machine algorithm. In phase 2A, they are importing and exporting data in Python, identifying and handling missing values, data formatting and data normalization. Phase 2B, they are develop recursive feature selection, which is RFE with random forest classifier. By completing these 2 phases, the second goal of the study, which is to develop recursive feature elimination support vector machine approach, is in selecting significant features of heart failure, will be achieved. Now we will look into the phase 3 and phase 4, which is the result analysis and discussion phase and the testing and evaluation phase. The dataset will be divided into 2 groups, which are training datasets and testing dataset, where the data will be divided into 70 and 30% for all the dataset instance, where the 70% is for training and 30% is for testing. The results of the performance classification from the model with applying feature selection will be obtained and compared. The performance of the classification will be evaluated in terms of accuracy, precision and recall. By the end of the phase, the last objective of the research, which is to evaluate the heart failure performance using RFE SVM, will be acquiring accuracy, precision and recall will be achieved. This is my dataset from Kegel with 918 observation and 12 attributes. Now we will look into the performance measures. What is performance measurement? Performance measurement is used to evaluate the efficacy and efficiency of the project. And confusion matrix is used to summarize the performance of a classification method. We have 4 points, which is true positive, true negative, false positive and false negative. True positive is the result of the model correctly predicting the positive class, while true negative is the result of model correctly predicting the negative class. For false positive is the result of model incorrectly predicting the positive class. Meanwhile, false negative is the result of model incorrectly predicting the negative class. These are the equation for accuracy, sensitivity and precision using the true positive, true negative, false positive and false negative. Now we will look into the software and hardware requirements. For software, we need Windows 10, Visual Studio Code for Python, Microsoft Excel and Microsoft Office. For hardware requirements, of course, we need a laptop with Intel Core i5 processor, 4 GB of RAM and a backup drive. Now we will enter chapter 4, which is design and implementation, where the pre-processing step will be discussed. Recursive feature elimination also will be carried out in the feature selection method. The output of the code will be provided with the explanation. Now we will look into the proposed solution. There are 4 proposed solutions, where it will begin with collecting the dataset from Kegel and undergoes pre-processing, where checking missing value and data normalization together with data formatting and descriptive analysis. Finally, the RFE will be executed to eliminate any irrelevant attributes. Now we will look into the data preparation. The dataset included in this research has been taken from Kegel, as mentioned previously, with 918 observation. It also consists of 12 features, which may be classified into 2 categories, which are quantitative and qualitative features. The total number of quantitative features is 7, and whereas the qualitative features will be 5. Now we will look into data preprocessing, which is checking missing value. In this checking missing value, we have been used isNull and sum function. From this image, we can see that there are no missing value. Now we will look into the outliers. There are 4 features that contains outliers, which are resting blood pressure, maximum heart rate, old peak and cholesterol. For resting blood pressure, there are a lot of outliers above the box plot and but only 2 below the box plot. But for maximum heart rate, there are only 2 outliers below the box plot. Same as resting blood pressure, old peak also have a lot of outliers above the box plot but only 1 below the box plot. But for cholesterol, there are a lot of outliers above and below the box plot. These outliers of these attributes will be replaced by their standard deviation value or median value. This is because mode and mean values are influenced by the outliers. These are the image of the 4 features where after removing the outliers. Now we will look into label encoding. Label encoding is a process of changing categorical value to numerical value. In this dataset, there are 5 categorical values which are sex, chest pain type, resting ECG, exercise angina and ST slope. For sex, there are only 2 values which are male or female, therefore they has been changed to 0 or 1. Same as exercise angina where it is no or yes. For chest pain type, there are 4 chest pain type, therefore it has been changed to 1, 2, 3 or 4. For resting ECG and ST slope, there are 3 type of values, so it has been changed to 0, 1 and 2. Now we will look into data normalization. Data normalization uniforms the instant value from various ranges into range 0 to 1. In this data normalization, min-max scalar has been used, which allow features to be from 0 to 1. This is the function has been used for min-max scalar. From this image, we can see that all peak after doing the data normalization. Before data normalization, the value of all peak has been ranged from negative 2.6 to 6.2. After normalization, the value from 0 to 1. Now we will look into data formatting. The values of normalized data of all peak is rounded off to 2 decimal places from 6 decimal places, as we can see in the image below. Now we will look into binning. What is binning? Binning is the process of categorizing the data into certain groups, which will be helpful to find at which number of age people are at high risk and how many people falls under the risk zone of cholesterol and resting blood pressure. There are 3 features involved in this binning, which are age, resting blood pressure and cholesterol. In age, we can see that there are more than 350 people involved at the age from 49 to 59 as a patient. For resting blood pressure, we can see that around more than 200 people have the resting blood pressure from 120 to 130, which is considered as a hypertensive crisis. Only there's no people are in the healthy range because everyone is has the resting blood pressure more than 80. Therefore, everyone falls under the hypertension stage. For cholesterol binning, we can see that around near to 250 people have a cholesterol from 200 to 240, which is considered as a danger level. And we can also see that around 4 people has a cholesterol level from 400 to 440, which is also considered as a high risk level. This is the descriptive statistics of the research, where we can see the mean, standard deviation, minimum and maximum value, and the percentile of continuous variable of each and every quantitative attributes. From this table, we can see that sex, chest pain type, fasting BS, resting ECG, exercise angina, old pig, ST slope, and heart disease represents a value like yes or no, male or female, types such as normal, peak, low, like that. But only resting blood pressure, age, cholesterol, maximum heart rate represents their patient's value, where there's original mean, standard deviation value, their percentile of continuous variable. Now we will look into the recursive feature elimination. For recursive feature elimination, the RFE will select the features by eliminating less important features. For this research, only 8 types of features has been chosen, which are age, chest pain type, resting blood pressure, cholesterol, fasting BS, resting ECG, maximum heart rate, and old peak. Let's go into summary. The data preprocessing has been covered, which includes checking missing values, treating outliers, labeling, encoding, and data normalization, data formatting, binning, descriptive analysis, including RFE. For each surface of this data preprocessing and feature selection in this phase 2, the output code is provided with explanation. The descriptive data analysis also has been included, like has been shown before. Now we will look into chapter 5, which is conclusion and recommendation. A detailed research cap was done on the previous research paper, where the first objective has been achieved. Not only that, the framework is designed to accomplish the data preparation, data pre-processing, feature selection and classification. Through the feature selection phase, the second objective has been achieved. In future works, I'll be implementing the SVM in predicting heart failure, especially in phase 3 on final year project 2. The results obtained will be used for training and testing and evaluation process in phase 4, which will be compared and discussed before the final part, which is thesis writing. The expected output of this research will be acquiring a high accuracy in the prediction of heart failure using support vector machine. That's all from me. Thank you.